Today we're going to take a look at the difference in physical changes, chemical changes, and really we're going to focus on the signs of a chemical change. So come on in and let's take a look. Let me get my desk all set up and we'll be right back. Well, in this chapter we talk about the difference in a physical change and a chemical change. So we kind of want to take a look at that and make sure we can recognize the differences. Now, the real test, if you will, what it all comes down to is a new substance created at the molecular level, have the bonds broken and rearranged. Well, that's incredibly hard to see, so fortunately we kind of have some signs of chemical change. Let's start with physical change because it's pretty straightforward. Take something like a piece of paper, right? Well, it's square, basically two-dimensional, smooth. Well, I can do something like tear it in half, right? Well, it's a new shape, it's a new size, but it's still paper. I can crumple it up into a ball. Now it's three-dimensional, it's bumpy, it's not smooth, so its shape, its size, and texture has changed, but it's still paper. I don't fundamentally have a new substance. Same kind of thing with wood, right? Now I can take a tree and I can chop it up into coffee stirs, but it's still wood, right? I can snap my coffee stir in half, but it's still wood. I can change the shape, etc. Physical change. Now we could have a state change, right? Water especially. I could have liquid water, I could have solid water in the form of ice. It's still water, so it's a physical change. But let's take a look at some chemical changes and kind of note the difference between them. Now, one of the classic, I could take my piece of wood, right, and I could burn it. Now, I don't want it to run too long because I don't want to set off any fire alarms. But at this point, what's left here isn't wood anymore. Ash, or carbon, let's see some of it going up in smokes. We get color, light, or energy, right? Several things going on for a sign, but kind of that real test. What I burned away, a little tiny bit of it there, bit of ash, right? Well, it's no longer wood, it's a different substance. Let's look at some others. Now, when it comes down to it, there are some signs, right? Reason that I think a chemical change may have taken place. Some of these you probably know. Well, let's take one like color, right? This is a sign of a chemical change, a color change. Well, it depends. If I take something like this, yellow and blue, and I add it in there, and get it all nice and mixed up, right? Well, it turns green. No? Is that a chemical change? We had a color change, right? Well, yeah, we did have a color change, but it's just a physical change. It was paint before, it's still paint now. And really with a color change, if I mix yellow and blue together, I expect green. That's how we make green. If I mix blue and red, we get purple. So when we say a color change, what we mean is an unusual, an unexpected color change. Let's take a look at a couple. This is universal indicator fluid, green. I guess we highlight it up against here. Now, if I take a clear liquid, right, and I add it to it, well, now it turns blue. Sign of a chemical change, right? Not something we would expect. A clear liquid into green should have had no effect, but in fact it turned blue. Another one, here we have a clear, at least reasonably clear liquid, and I have another clear liquid, and if I add it to it, ooh, look at that. Nice dark purple color. This is a sign of a chemical change. It's really an unexpected change. Kind of fun with this one. I can pour it into my hands, but if I rub it around into my hands, it also disappears, right? So it changed from purple back to clear. Something like that. Rub it all out. So chemical change. This is when we have an unexpected color change. Better way to look at it. Well, some other things that we can have is energy, right? Now, energy could come up in several things. We could talk about it giving off light or giving off heat. It could even take away heat. If something cools off unexpectedly, this is a sign, but it all comes down to energy. So we kind of burned a stick, if you will, and that's one common form. Well, another really is, right? Combustion, right? This is a chemical change. This is alcohol, C3H7OH, in the presence of a spark. Then it turns into carbon dioxide and water vapor. The C, O, and the H break apart, reform into new substances. Alcohol ceases to exist, and we have the creation of carbon dioxide and water vapor. So, and we saw, you could feel the heat. Of course, you couldn't feel it there. I could hear, we could see the light. So we have an energy change. Another one, or another sign of a chemical change, is a formation of a gas. Now, in this case, I'm taking hydrogen peroxide. Now, this isn't the hydrogen peroxide you can easily get a hold of at your local drugstore. This is 30%. Well, hydrogen peroxide, H2O2, doesn't really like to be hydrogen peroxide. It decomposes into H2O and O2. And that's going to happen if we watched it, because you know it says on the bottle, keep it in the dark, away from heat, because it will decompose. Now I'm going to add some manganese dioxide as a catalyst so we can see what occurs. But once again, formation of a gas. And wow, look at that. This formation of a gas, once again, is sign of a chemical change. Now, if I kind of show you the thermometer here, and then drop it in there for just a bit, we'll also notice this is a exothermic reaction. It gives off heat. So if we let that kind of sit in there for a minute and then take a look, we'll notice that it has increased its heat dramatically. So giving off of a gas, sometimes people call it the making bubbles, but it's really forming a gas, is another sign of a chemical change. Another one is the formation of a precipitate. Now once again, could be physical change, could be chemical change. If I put water in the freezer and it turns solid, well, this is a physical change. It's expected. So once again, we say formation of precipitate. Normally this is something odd. So here I have a clear liquid. Now this is really just an aqueous solution of lead nitrate. I just dissolve lead nitrate in water. And if I add potassium iodide to it, and the potassium iodide, it's a clear liquid, but if I add the potassium iodide to the lead nitrate, wow, look at that, beautiful color, cloudy yellow. This is the formation of a precipitate. Lead nitrate, potassium iodide turns into lead iodide. This is what the yellow is, and it will eventually settle out to the bottom as my precipitate. Well, we tell it's a precipitate because it went cloudy, right? It wasn't clear. This wound up staying clear. It wasn't a precipitate. We can still have light passing through it. Here, we had a precipitate form. So these are some of the signs of a chemical change. I have one more I'd like to show you because it's so many rolled up into one. We got to move over to the hood because this one is going to make enough smoke that I probably would set off the fire alarm. So let's head over to the hood and take a look at this final demonstration. All right, for this last demo, we're going to do it up under the hood because it is going to generate some smoke. note how many signs of a chemical change you can actually see. All right, here we go. This is the setup. We have some basic household sugar here. Just good old granulated sugar. And I have sulfuric acid. Now, this is the real deal sulfuric acid. So I'm going to add some of the sulfuric acid. I want to make sure that I am being cautious with this, as it is quite concentrated. Got a tiny bit more than I was really after, but should be fine. I'm going to talk through a little bit of this, and then I'm going to speed it up so we can watch it in time lapse. Obviously, pretty quickly, we get color change. It kind of goes from that yellow, it'll go into brown, and eventually kind of go a dark color. Like I say, we'll listen to some music and see what happens in time lapse. Yeah, wow, take a look at that. I wish you could, there's a smell here as well. Literally kind of like burned sugar. We can still see it's coming here. This is actually also very hot to touch. So it's an exothermic reaction again. We see lots of the signs, right? We saw color change. We saw formation of a gas. If I had a thermometer in here, we could get the temperature, gave off a lot of heat. And I'm getting a pretty strong smell, because this is like quite literally burned sugar at this point. Wow, pretty amazing. And there we go, right? Signs of physical and both chemical change, right? Who knew? Some of these things are kind of fun. Guys, you got to have a little fun along the way. So hopefully that can help clear some of this up. Take care. We'll see you next time.